The application suite is a single integrated platform with key monitoring, maintenance, and reliability applications with a modern componentized architecture built for scale. It's designed for enhanced data sharing across all of our applications, providing an integrated end-user experience with things like single sign-on and shared administrative controls for enterprise-scale execution. It's architected for a multi-cloud and hybrid deployment. It's built on Red Hat's OpenShift container platform and is optimized for scale and availability for deployments on-premises, private, and public clouds. Now, I want to focus on three key capabilities for this demo. The first one is monitor. Our monitoring capability is for real-time visibility, root cause troubleshooting, and AI-powered remote monitoring at scale for improved asset and operational availability. Second area is around our mobility, and we'll show you our next-generation technology for the technician, allowing him to perform his job better, all through a more modern digital tool. And then finally, health, representing a new way of maintaining equipment, one based not only on current condition-based readings coming from your equipment, but also informed by other influences like age, maintenance history, weather, and cost factors. But first, let me start by introducing the company for this demo, Protective Eye Glasses Incorporated. Now, this company manufactures both the lenses and the frames of stylish glasses, which are sold on a global scale and are in high demand by all age groups. The factory runs 7/24, but struggling with unplanned downtime, so much so that they are planning to invest about $40 million into a factory expansion just to meet demand.
Let me introduce David. David is the operations manager for PEGI. To do his job, he needs an overview state for all of his assets. He relies heavily on KPIs for insight and the ability to drill into those details and take action on root cause. David logs into the Maximo application suite to check his customized monitor dashboard to find out more information about what happened and take necessary actions. He views a modern user interface showing him all applications installed that he has access to. He selects Monitor. Once in the Monitor homepage, he can easily switch between applications. David chooses his dashboard view. Once in the dashboard view, David can see key metrics that he and the team are measured against, such as site availability, overall equipment effectiveness, and performance. It's pretty clear that there's a problem with the overall equipment effectiveness due to availability of the assets in production. David looks at the factory view and sees an alarm over one of the sites. As he moves his mouse over the alarmed area to view details, he sees that line 13 has stopped production and has several alarms associated with it. David can easily filter down to line 13 from the summary control view, which brings him to a detail view of line 13 specifically. Once in the detail view of line 13, he looks below at the production downtime graph to ascertain as to whether or not this downtime was planned. It's evident this was unplanned and that there's a big problem that must be resolved quickly to prevent missed revenue. He can scroll down further to see the alerts. He sees 3 high-severity alerts due to the asset stopping production and from an anomaly detected on the torque of the robot arm. David wants to investigate further and clicks onto the entity ID of the problem asset Robot 13A1. Here he sees the overview of Robot 13A1 and sees an error message on the picture. He can see that the problem was with servo motor M. He knows this needs to be fixed immediately, so he decides to create a service request. He clicks all 3 assets and then clicks Create Service Request. Once clicking Create, the dialog box for service request populates all the key information. He clicks Create, which sends the service request directly into Maximo. Immediately after creating the service request number is populated on the corresponding rows with a hyperlink that will open up in Maximo directly. Bob can now access the Maximo service request right from within Monitor, so he doesn't have to go to a different application. Now that the work orders are in place, Bob can continue with the rest of his day. Now that Kevin has submitted the service request, the work supervisor assigns the job to one of the plant technicians, Sam. Once the work order is assigned, Sam is alerted immediately on his smart device. He opens the work order. He heads to the storeroom to pick up materials for the job. Sam quickly issues the materials to himself. Now that he has the materials, he can start work. Before deciding what repairs are necessary, Sam performs the inspection on the work order. From the inspection, he determines that the robot arm motor is close to failure and needs to be replaced before it causes collateral damage. Maximo generates necessary tasks for Sam to complete. He clicks on the task list next. As he starts his tasks, Sam realizes that he is not completely sure how to replace the lower motor of the robot arm. He clicks on Assist for help. Assist leverages AI with human expertise to provide technicians guidance on the right actions relevant to the repair. Maintenance or operation of an asset, from manufacturer and owner manuals, all the way to historical work orders, engineering processes, even a custom training repository. Assist shows Sam several recommendations on how to replace the motor arm, along with confidence levels. The top recommendation, with an 80% confidence level, looks right to him. He selects it to see the original document. Sam now has what he needs to complete the repair. Now that the repair is finished, he marks the work order as complete, selects Done, and closes out the work order. Let's move on to our last persona, Marcia, the reliability engineer. The primary role of the reliability engineer is to identify and manage asset reliability risks that could adversely affect plant or business operations. After hearing about this critical failure, Marcia logs into Asset Health and Predict to view the poor health work queue to see if other robots could be trending towards similar problems. This work queue simply queries all assets that are exhibiting a low health score. She can also query assets with missing data or high probability of predicted failure. After clicking into the low health work queue, Marcia can see all assets sorted by low health, highlighting problem assets up front. She can also see other key metrics such as predicted failure date, age, and total cost of maintenance of the asset. When looking closer, she notices that another robot arm has just decreased to poor health, so she decides to investigate that asset further. Marcia sees all key health indicators on this form, including criticality, age, and maintenance cost compared to replacement value, to better understand the risk associated with the asset failing. Investigating further, she can see the health of the asset has dropped drastically in the past few days, indicating a recent problem. She can also see the condition data, which came from monitor, and maintenance cost versus budget is driving the health score lower. She scrolls down to view the predictive failure models to glean more information. By leveraging IBM's advanced analytics with machine learning, she's able to see that a failure is predicted in the next 90 days, with a 10-day confidence range due to the lower server motor overheating. Likewise, she can see the probability of failure has increased, showing the same failure mode. These are two different models that corroborate an imminent failure. Before creating a work order, Marcia wants to review the maintenance and inspection history for the asset to see if there has been recent maintenance activity. Though she sees that there was a recent maintenance activity, she decides to create a work order to address the problem. She takes action by creating a work order with an inspection to determine if further work or replacement of the asset is needed before this asset fails as well. Sam is assigned the work order and is able to fix it before it becomes a problem. Weeks later, after proactively using Maximo to address any identified risks, the operations engineer and reliability engineer can now see that overall equipment effectiveness has improved to above target levels, and that the problem assets are performing well with much fewer failures.
In summary, you just saw how IBM is integrating applications for a unified view of your enterprise operations. All of these capabilities are being delivered together in the IBM Maximo Application Suite 8.0, running on the IBM Cloud, powered by OpenShift, and can be deployed with your existing Maximo installation. This will allow you to achieve a complete view of your asset lifecycle management in order to better understand the full spectrum of preventative, predictive, and prescriptive maintenance actions needed. We are delivering the next generation of enterprise asset management by bringing your critical assets and your people together. Thank you.